All right, let's get started on the notes here. So you're on 1.2 notes, which would be in the packet, the yellow packet, which is the notes packet there. I'm going to disappear there. Okay, so we're going to go over multiplying exponents and the rule about the multiplication rule with exponents right here. But let's just go over some basic terminology before we actually go over the rule here. So we all know what an exponent is. So let's say I have a 3, and next to it I have a variable like an x, and then above the x I have an exponent, let's say the 4 there. Okay, so couple things about this. Let's just learn the terminology so that when I say things, you're aware of that. So that value where the 4 is, it's obviously not always a 4. That is what we call the exponent. It's always written a little bit smaller than like a smaller font, and it's always raised up. Okay, anytime you see a letter in math, like an X, doesn't have to be an X, it could be any one of the 26 letters in the alphabet. That is what we refer to as a variable. So letters in math are referred to as variables. And then if you see a number in front of the variable, like in this case a 3, it obviously doesn't have to be a 3, but it will be a number. And if you see one in front of a variable, remember a variable once again is a letter in math, that is called the coefficient. Okay, C-O-E-F-F-I-C-I-E-N-T, the coefficient. So we've got coefficients, that's the number in front of a variable. A variable is a letter, and then we have exponents, which in this case would be the 4. Okay, so there's a rule in math, and this is the exponent, the multiplication rule of exponents that we're going over right here. And this is the one that we're going to use a lot in this particular idea that we're going to be talking about today. It's the multiplication rule with exponents. And I'll give you the rule in a very general sense, and then I'll show you a couple examples of how it works. Okay, so this is the rule. If we have x with an exponent of n, and then you're going to multiply that with x with an exponent of m, this is what the multiplication rule of exponents says. It says that is equal to x with an exponent of n plus m. So notice that the variables are the same, x and x. And what you do is when you're multiplying, you leave whatever the variable is, x, and then you add the exponent values up. So you actually don't multiply the exponent values, you add them up, okay? So in a very easy sense, let's say we have x to the 3rd power, and we are multiplying it with x to the 4th power. The answer, this would simplify to x, and then you don't multiply the 3 and the 4, you add the 3 and the 4 together. And since 3 plus 4 is equal to 7, this would simplify to x to the 7th power. Okay, so x to the 3rd power multiplied with x to the 4th power would simplify to x to the 7th power. So that's the multiplication rule with exponents, okay? Now, the question becomes, what happens if you have a coefficient? So let's say you have 2, and then you have a y, we'll use y as the variable now, with an exponent of 7, and you're going to multiply that with 6, and the variable is y. The variables have to be the same in order for this rule to apply. So you can't have like a y and an x. Okay, and then this y, this other y has a variable of, let's say, what number haven't we? A 4. Okay, so here's the rule on this one. When you're multiplying this and you have coefficients, the coefficients would be the things in red, the numbers in red, the 2 and the 6. Remember, a coefficient is a number that's in front of a variable. So the rule on this is, this particular example would simplify to, you actually multiply the coefficients. So you would go 2 times 6, and then you would have the y, and then you would apply the multiplication rule of the exponents where you would add the 7 and the 4 up. Okay, so multiply the numbers in front. If there are numbers in front, multiply them, 2 times 6, and then you add the exponents together. And then the variable, you just kind of smush those two y's together and make it one y. Okay, so this would, of course, become 12. 2 times 6 is 12. Then we would have a y, and then we would have an exponent of 11. So this particular problem would simplify to 12y with an exponent of 11. Okay, all right, last thing is, if you don't see an exponent, so let's say I say, let's take x, and let's multiply it with x, and let's multiply it with x, and that third x has an exponent of 5. Okay, so what do we do here? All right, so the thing that you need to remember, absolutely need to remember is that if something is not showing as having an exponent, it actually has an exponent. It's invisible, okay? So this first x right here actually has an exponent. It's invisible, and it's invisible as a 1. Okay, and the second x has an exponent that's a 1. So the x's, if you don't see an exponent, you have to know that the exponent is a 1. So we would now use the multiplication rule with exponents. We would smush all the x's together. So we would have an x, and then we would add the exponents up. 1 plus 1 plus 5. So this would simplify to x to the 7th power. All right, and so that's what that problem would simplify to. All right, guys, so there's kind of the rule of the exponents. Now, we're going to apply that rule we're going to apply this rule, this multiplication rule with exponents, and then we're going to use it to multiply what we call a binomial times a binomial. Okay, so the first thing is that, what the heck does this word binomial mean? All right, so let's just kind of get a quick definition of what a binomial is. It might be something that you have heard before. You probably have, but if you don't, no big deal. So a binomial is any expression with two different terms. Okay, so a binomial is going to be any mathematical expression that has two different terms. You will find out that the terms are always separated by an addition or a subtraction symbol. And what we're going to do is we're going to go over, how do you take a binomial, and here's an example of a binomial, x plus 8, and how do you multiply it with another binomial, like x plus 3. Okay, so x plus 8, that is a binomial. Why is it a binomial? Well, because x is different than 8, so we have two different terms. X plus 3 is a binomial. Why is x plus 3 a binomial? Because x is different than 3. Those are two different terms, okay? And what we're going to do is we are going to multiply these two binomials together by incorporating this rectangle here. And notice that it's a big rectangle, and it's divided up into 4 smaller rectangles. And here's how we do it. We're going to take the first term, the x plus 8, and we're going to write it along the outside, along the top of the rectangle. So we're going to put an x, we're going to plus, and an 8. Then we're going to take the second parentheses, x plus 3, and we're going to write it along the outside, along the side, outside of the rectangle, like this. Okay, and then what we're going to do is we are going to multiply always the length times the width of each rectangle. The value that would represent the length and the value that would represent the width of each rectangle. And then we're going to be using this multiplication rule with exponents, And we're going to be then filling in inside each rectangle, okay? This is something that I believe you guys did in Math 1, so this should be familiar to you. All right, but let me show you what I mean by what we're going to be doing here. And I'm kind of color coding each length and width here. All right, well, I'm going to use green for this one right here, for these two. And then do I have another? Oh, I got orange. Okay, so I'm going to use orange for this one and this one here. Okay, so every length that's in red represents that top outside X right there. Okay, so we have an X and an X. That's the red. Okay. The green represents the width, which is represented by the outside left X. And like I said, what we're going to do is we are going to always multiply in each individual rectangle the length times the width. So when I go over here to this top right rectangle, the length has a value of 8. It's represented by the color purple, and it's a positive 8. Okay, and then when I go down to this bottom right rectangle, the length is represented by the 8, and the width is represented by the 3, which I'll do in orange here. Okay, so that would be a 3 right there. So this bottom left rectangle here, I would take the length, which is represented by the outside top X, times the width, which is represented by the outside left 3 here. And then what I'm going to do is I'm going to multiply these together, and I'm going to write what the result of each multiplication is. So for instance, let's start at the bottom right rectangle. 8 times 3 is 24. So I'm going to write a big 24 right there. In the top right rectangle, 8 times x is 8x. In the bottom left rectangle, x times 3, we represent that as 3x. And in the top left rectangle, x times x, because neither one of those x's have an exponent, that means each of them has a 1. Remember, if you don't see an exponent, it's an invisible 1. It's there, but it's a 1. And then we use the multiplication rule of exponents. We add those up. So this would simplify, the top left rectangle would simplify to x to the second power. Okay, and so then your result, your answer, is the combination of all 4 rectangles put together. So what this tells us is that when I take x plus 8, the binomial x plus 8, and I multiply it with the binomial x plus 3, it is equal to the result of all 4 of these rectangles, okay? So it's equal to x squared. And then I have a positive 8x, so I put plus 8x. And why did I put plus 8x? Because that 8x is positive. Then I'm going to go down to the 3x. That is positive, and so I put positive 3x. And then I go down to the 24, and because 24 is positive, I put plus 24. Okay, and that right there, that x squared plus 8x plus 3x plus 24, that is your answer. But here's the catch. It's only your answer if it cannot be simplified. And as you could obviously see, you can simplify this, and you can simplify it by combining the positive 8x with the positive 3x. So really, this tells us that when I take the binomial x plus 8, and I multiply it with the binomial x plus 3, that is equal to, in simplest form, x to the second power plus 11x, positive 8x plus 3x becomes 11x plus 24. Okay, so that's what we're looking at in this particular lesson here, is how do you multiply 2 binomials together? All right, let's go to the next example, which would be this other rectangle here. I'm going to try to squeeze in this next example here. And what we're going to do is we're going to take the binomial, and let's go with x plus 10. You know what? Let's make it a little more challenging. Let's go with 3x plus 10. And then we're going to multiply it with the binomial 2x minus 4. All right, so how do we do this? Well, we take what's in the first parentheses, the 3x plus 10. We write that along the outside top of this is called an area model, this rectangle here. I take what's in the second parentheses, 2x minus 4, and I write that along the outside on the left. And notice how I wrote the minus 4. I put the 2x, and then I put the minus 4. So that minus 4, we're going to know that is a negative 4. And then what I'm going to do is I'm always going to take the length of each rectangle, which will be 3x, and I will, in this top left rectangle, and then I will multiply it with the width of each rectangle, which in this top left rectangle is going to be the 2x. So to figure out what goes in that top left rectangle, I go length times width, 3x times 2x. Now remember, each one of those x's has an exponent of 1. So, and we're going to apply the multiplication rule. Well, here we have these coefficients, the numbers in front of the x's, okay, the 2 and the 3. So you multiply those. 2 times 3 is 6. We have an x, and then we're going to add the 1 and the 1 up. So that top left rectangle becomes 6x to the second power. Okay, moving to the top right rectangle, the length is represented by the number 10. So I'm going to always go length times width. So I'm going to go 10 times, and then the width is represented by the 2x. 10 times 2x is equal to 20x. So I write a 20x in this top right rectangle. Moving to the bottom right rectangle, I'm going to take the length, which we have already determined is represented by that positive 10. And then the width of that bottom right rectangle is represented by that minus or negative 4. So I'm going to go 10 times negative 4. That is equal to negative 40. Okay, and then the last rectangle, the bottom left rectangle, I'm going to take the length of it, which we already determined was 3x. And then I'm going to multiply it with the width, which we determined was that minus 4 or that negative 4. And 3x times negative 4 is equal to negative 12x. Okay, so then once again, remember your answer is the combination of all 4 of the inside rectangles. So that tells me that the binomial 3x plus 10 multiplied with the binomial 2x minus 4, it is equal to 6x squared, that's the top left rectangle, plus 20x. Why did I put plus 20x? Because the 20x is positive, minus 12x. Why did I put minus 12x? Because it's a negative 12x, minus 40. Why did I put negative 40? Well, the answer is because that 40 is negative. All right, and that's your answer right there. 6x squared plus 20x minus 12x minus 40. However, as you can see, once again, we can combine the positive 20x with the minus 12x. So I always want to write my answer in its simplest, most combined version. So this tells me that when I take the binomial 3x plus 10 and I multiply it with the binomial 2x minus 4, it is equal to 6x squared, positive 20x minus 12x becomes positive 8x, 20 minus 12 is 8, minus 40. And that's my solution that I'm working towards right there, okay? All right, one more example to go. And as you can see in your notes, the last example would be, we're going to use the area model. And the area model, that's that rectangle there with the 4 pieces. And we're going to use it to multiply a binomial to the second power. So what do I mean by a binomial to the second power? Here's what I mean. You have a binomial like x plus 5, and it's in parentheses. And there's not another binomial next to it. But outside the parentheses, there is a second power. Okay, so here's the thing that you have to remember. The second power, what it tells you is that the meaning of it is that, so for instance, let's say I say take 7 to the second power. And I ask you, what does that mean? Okay, not what it equals, but what does it mean? Okay, so it means 7 times 7. Okay, so the second power tells me to multiply the 7 with itself, 7 times 7, okay? If it was, say, a third power, say if we had a 9 to the third power, that, of course, means you're going to go 9 times 9 times 9. Okay, so when you see a parentheses x plus 5 to the second power, that means you're going to multiply x plus 5. And because it's a second power, you're going to multiply it with itself. Okay, so how would I do this? This is where I would use the area model. I would write an x plus 5 on the outside on the top. That's for the first parentheses. And then the second parentheses, which is also x plus 5, I would write that along the outside on the side. Okay, and then I'm going to fill in each one of the 4 inside rectangles here. Always using the concept of length times width. Okay, so the length, we're going to start with the top left rectangle. The length is represented by x. I'm going to multiply it with the width, which is also represented by x. Remember, both of these x's have an exponent of a 1. So that becomes, that top left rectangle becomes x to the second power. That's going to be part of my answer. Moving to the top right rectangle, I'm going to take the length of the rectangle, which is represented by the positive 5, and I'm going to multiply it with the width, which I determined was that blue x there. 5 times x is 5x. Positive 5x. That 5x is going to be part of my answer. Okay, moving to the bottom right rectangle, I'm going to take the length, which is that positive 5. I'm going to multiply it with the width, which is also positive 5, and 5 times 5 is 25. So the bottom right rectangle, I put a 25 there. That 25 is part of my answer. Bottom left rectangle, I'm going to take the length, which is that red x, times the width, which is that green 5. X times 5 is 5x. And that 5x is part of my answer. So what this area model, this rectangle, these 4 rectangles tell me is that when I take the binomial x plus 5, and when it's to the second power, it is equal to x squared plus 5x plus 5x plus 25. Why are they both plus 5x? Because each of the 5x's were positive. And why is it a plus 25? Because the 25 was positive. And once again, that's your answer. If it cannot be simplified, but as you can see, I can combine, I can put together these 5 x's. So really, my solution is the binomial x plus 5 to the second power is equal to x squared plus 10x, positive 5x plus 5x is 10x, plus 25. Okay, and that's the solution that we're looking for right there. Okay, so there you go, guys. That would be your notes once again for section 1.2. All right.